That's a little easier. Okay, so I divided this talk into 5 categories, and rather than wait until the end or interrupt to do questions, I wanted to sort of at the end of each of these 5 areas, if anybody has any questions or clarifications, please just ask them, because I think that everybody's heard a lot about lithium, but there's a lot of information out there that's not so informative. So starting out with just the basics of lithium. What is lithium? So lithium is the lightest or least dense metal that exists on Earth. If you guys remember the periodic table, lithium is up there with the atomic number of 3, meaning that it's the 3rd lightest element in the entire world. The qualities or the characteristics of lithium's density and energy density allows for that high performance batteries that are smaller and last longer than using any other metal. But because lithium is so highly reactive, it never occurs freely in nature. It only occurs in compounds. So when we talk about lithium extraction, we're talking about finding lithium that is chemically combined with other elements and using it to create other chemical combinations, because lithium on its own is unstable. The next question is, where do you find lithium? So as you can see by this map here, there are lithium deposits on every continent. There are lithium resources and reserves all over the world, because lithium is abundant. It is a very abundant chemical, and there are deposits on every continent, and new discoveries are made constantly. So you'll see here, you don't see Peru outlined. Since this map was made, they've made a lithium discovery, an important lithium discovery in Peru, and it has been defined as a resource. So because of the interest in lithium, discoveries are made frequently. And for sort of a point of reference, seawater itself contains 0.17 milligrams of lithium per liter. The brines that we're going to talk about later that are used in Argentina to extract lithium contain 4,000 milligrams per liter. So there's a major difference, but it's important to understand if someone says, oh, there's a lithium deposit, to get an idea of how it stacks up against other lithium deposits in the world to see if it could ever be economically viable to use for lithium extraction. So the next question is, what does a lithium deposit look like? I brought with me to this talk, lithium in brine is what we're usually talking about in Argentina. Brine is salmuera, and you'll see that when you buy olives. Brine just means a salty water or an electrolyte liquid substance. And so Argentina's brines are located underground in the northern provinces of Salta, Jujuy, and Catamarca, under the salt lakes or salares. There's also lithium in hard rock, where it occurs as a lithium oxide in a spodumene crystal. I brought this, which you can see, this kind of square, blocky green crystal. That is a spodumene crystal, which contains 6% lithium oxide. This is from a hard rock deposit in China, but there are exploration projects for lithium in spodumene or in hard rock currently in San Luis here in Argentina. So I'm going to pass this around. And then there's lithium in clay and other deposits that formed at the later stages of volcanic eruption processes. I didn't bring any clay, but these are from Peru, and it looks like a chalk, but this is essentially a substance where a volcanic eruption, hold on just a second. I got it. So this is a lithium where a volcanic eruption has created little microscopic blobs of lithium-bearing glass that you can kind of see if you look at the way that the stratification is. And if I'm passing this around and you want to take some of the water from your cup and get the rock wet so you can look at the lines, go to town. These are cool. These are dendrites. This is one of the way that when you're exploring for minerals in general, exploration geologists know markers that will give clues to what's present in the substance so that they can look for additional. These are dendrites that were either formed by manganese or magnesium, and they look like little roots. So I thought that was cool, and they show the crystalline structure that you can't see visibly. So I'm going to send these